Microprocessor and microcontroller fundamentals and differences. A microprocessor is a multi-purpose programmable clock-driven resistor-based electronic device made of several millions of transistors that reads binary instructions from a storage device called memory, accepts binary data as input and processes data according to those instructions and provide the results as output. Here is a picture of 8085 microprocessor training. Microprocessor is essentially a CPU consisting of ALU, CU and register pairs. Arithmetic and logic unit performs the operations arithmetic and logic operations such as AND, OR, add, subtract, compare and so forth, and control unit defines the control flow of the instructions given. Input is given from the input pin. For example, the data is fetched from the memory with the help of addresses or directly. The microprocessor processes it, and then the output is outputted and stored either in an address or to an output peripheral. As you can see in the 8085 microprocessor pin diagram here, A to A15 are address buses which are 16-bit and unidirectional. AD0 to AD7 are data buses which are 8-bit and bidirectional. 8-bit because 8085 is essentially an 8-bit processor, its word power is 8-bit, and there are a bunch of many more pins, for example IO and IO/M pin, which helps in interacting with the memory and the external input peripherals, and we have read and write pins and so forth. Word power of a processor. At a particular time, the maximum number of bits that a microprocessor can handle. So most popular microprocessors today are 64 or 32 bits. However, the earlier 16 and 8-bit microprocessors are also available. A microprocessor can use either a complex instruction set computing or a reduced instruction set computing. CISC is used in desktop computing, is more flexible in terms of executing new set of assembly code. That is, it is not hard coded. For example, Intel microprocessors. And RISC computing is used essentially in embedded systems, and it follows one load store architecture and is not very flexible. For example, 8081 and 8085 a simple program in C, a high level language. It simply prints the words hello world on the screen. When it is compiled, it is translated to assembly code before getting translated to the machine code. To see what the assembly code looks like, I'll be using a bunch of Linux commands. First, I'll execute the program here. It prints hello world. Then I'll use another instruction, another command that will print the first 20 codes of the assembly language, the assembly code that the program got translated to. These are known as mnemonics. These are the instructions that we give while writing in assembly language. An individual code instruction, for example move, is called an opt code, and a hex code associated with it is the 89. So move and 89 are essentially the same. 89 is a hex code that the computer understands so that it executes the move command. What it is essentially doing is that it is transferring the data from accumulator register into the counter register. So this is how the assembly language and the assembly code looks like. Difference between a microprocessor and microcontroller. Microprocessor doesn't contain any memory or any other peripherals. It is simply and essentially a processing unit, a CPU. Microcontroller, on the other hand, does contain memory and peripheral support and is embedded in the embedded chip itself. Microprocessor find applications where the input-output relationship is not defined. For example, in photo editing, creating documents, games, websites, they need high amount of resources like RAM, ROM, input-output ports, etc. Microcontrollers are designed to perform specific tasks. By specific, it is meant that the relationship between input and output is clearly defined. Microprocessors are used in PCs, workstations, laptops, servers. Microcontrollers are used in coffee machines, automated floor systems, automated soft drink machines, tire pressure sensing machines, watermark sensors, etc. Microprocessor works on one or more gigahertz clock frequency. Cost is high and heat dissipated is more. On the other hand, microcontroller works well in the range of 30 to 50 megahertz clock frequency. Cost is low and the heat dissipated is extremely low.